that, but this session will be in English. Before we will start, I would like to say thank you to the organizers of this conference and to the partners of this conference. So it's very cool that we have such big events these days, and a lot of companies who supported this event. So thank you everyone who joined here in our room, for you who will come here, who came here. So and thank you for organizers, and special thank for Mikhail Mateev, who invited and approved my session also here. So my name is Alexander Surkov. I am Microsoft MVP since 2016. Right now I'm living in Lyon in France, and I'm working in a big transportation company. I'm responsible for cloud infrastructure, cloud migrations, and also I manage some small development team who works on the bug fixes and evolutions of some applications. And in general, our goal is to help product owners to support something like 8 applications, internal applications that are used to inside of life cycle, you know, of some buses, trams, transportation, and some management tasks. Also, I have the Microsoft MCT, so I'm certified trainer Microsoft. Periodically I give some official Microsoft courses about the cloud and DevOps, and I have several certifications around the cloud and DevOps also from Microsoft and Terraform. What we will talk about today? I already presented you that we will talk about the Azure App Services. Do you know, first of all, for me to understand how deep I need to dive inside of different topics, who worked before with Azure? Can you? Okay, not many. And did you work with App Services before? Okay, that's great. So maybe you will know most of the part that I will give you today, but maybe I will give you some interesting insights that me and our team personally we've met during our experience this year of cloud migrations. So first of all, since not a lot of people and one more question. Who work with other cloud providers like AWS, GCP? Okay. But not everyone. Okay, so since this next slide may be useful here, so why we need to start from the classical cloud terms, software as a service, platform as a service, and infrastructure as a service here, because we need to understand why we need to use app services if we can use, for example, just the virtual machines or even bare metal servers to deploy our application. This slide has the name in Microsoft like the shared responsibility. You know that all the 3 different layers of the cloud here share some responsibility with the cloud provider. For example, if you want to use your own bare metal or on-premise server, you will be responsible for everything, for electricity, for cooling, for operation system, to set up all the environment, etc., etc., etc. But if you want to create the virtual machine inside of the cloud provider will be responsible, for example, for the data centers, for the hardware, for electricity, for security, and you will be responsible only for the management of the middleware or frameworks inside of the operation system. Operation system will be also supported by cloud provider. On the platform as a service level, cloud provider will take more responsibility and give you a chance to work only with the features that you want to do and to not to work on the things that are outside of the scope of your task. For example, for like a database. So you as a developer, for example, you want just to store data in the database and read data from the database. Maybe execute some, create some indexes, etc., but to work with the data. And it's not your, how to say, your goal, and it's not inside of your scopes, the things about the creation of the database, settings of the database, I don't know, supporting updates that frequently comes to the database. And in this case, you will save a lot of time, and you can concentrate on only your topics if you will use the platform as a service services in any cloud. It can be AWS, Azure, so any cloud. And a couple of words about the software as a service. Here it is the ready-to-use, business ready-to-use applications that can be used by businesses usually without any additional coding. So platform as a service, it's like a bricks. The bricks that allow you to build your system, your application, to create environment for your application in the cloud with more fast, maybe a little bit more expensive, but more fast, and the result that you will have usually is better, because the part of the responsibility that will be taken by the cloud provider, they will do that with all their professional experience. So if we are not experts in the database, maybe it's better to give the management of the database to the cloud provider than to do it on our side. Better, faster, but a little bit more expensive. And the question is how to deploy and where to deploy your application. If you want to have the good SLA, 4 nines, 5 nines, etc., it's also the question, especially if the application is critical, how we will do with the scaling, how we will do with the, with the SLA. And of course, if we will just put our application in our on-premise server that we bought in our office, we will be responsible for everything, and all the hardware problems, all the network problems, all the electricity problems can decrease our SLA. If you don't know, SLA, it's like the server or service level agreement between the provider of the service or cloud and the client. So the cloud provider gives you commitment that their services will work as minimum, for example, 99% of all available time, 99% of all the time of the month. But 99% is very low level, and this means that your service can be down during several hours. So the good levels is 4 nines, 99.99, and more. And in this case, cloud provider tells you that your service theoretically can be down during, for example, 1 month, during 5 minutes, 2 minutes, or something like that. And to increase the SLA, we can select the special services that gives us the good SLA, or we can combine the services in the cloud. So the on-premise server will give you the lower SLA, because theoretically we have more chances to have the hardware, electricity, and other issues. If we will create just a virtual machine in the cloud, it also has some SLA like 99.9, but it also gives us possibility that we will lose our service for several hours during the month. And if we want to increase our SLA, and moreover, if you want to support scalability of our application, the most typical choice in the cloud will be like that. So it's the load balancer that has scale set under the load balancer, and it worked like that. So load balancer receive the input traffic, then it decides to which server this traffic should be sent, and then when server makes the response, the traffic comes to load balancer, and load balancer responds to the client. Why do we need to have this thing? Because we decrease the possibility of problems with the virtual machine. If one of the virtual machine will be broken, load balancer will understand that, because it periodically calls this virtual machine to understand, make the health check. And after that, the load balancer will send the traffic to another alive servers, live virtual machines, and at the same time they can have some automation, automated scalability. And if, for example, load balancer will understand that the traffic, amount of traffic increase some threshold, some level, it can send the message to the scale set, and scale set will create automatically several virtual machines. Or you can set up some additional rules to the scale set and to check, for example, CPU or memory usage of the virtual machines. And if CPU will increase, for example, 80% for 5 minutes, this means that there are a lot of clients who came to your application, the scale set will create automatically more virtual machines. And if the CPU usage will be lower than, for example, 20% for 5 minutes or for 10 minutes, it can reduce amount of the virtual machines. And this can help you to support the difference between, I don't know, between different days, different months. If you have the internet shop, and of course, if you have the sales time, discount time, the people, you will have more clients than usually, and for this case, you need to scale your backend. But in this case, what we will have the full control about everything. So we will be responsible for the load balancer, to create it, to set up it, and to check how does it work. We will be responsible to manage the scale set itself. And this is the good question. Do we really need to have this full control? Of course, the price will be a little bit lower, but we will have more responsibility, and we need to have much more, maybe even knowledge about that. So, do we really need this full control? Also, how we deploy our application. Is it lift and shift deployment? Lift and shift means when you have some already used application on the on-premise or some bare metal servers, and you want to put it in the cloud. In this case, you need to understand, is it possible to put this application inside of platform as a service services, or you just need to make the copy of your existing environment, of your existing servers inside of the cloud. It's possible to make the copy. It's one of the simplest way to deploy your application, to move your application to the cloud. But in this case, you just, you will not use the most powerful parts of the cloud, and you will be still responsible for a lot of things in your environment. And if it's not lift and shift, if it's application can be, if it's new application, or if you can modify your application to support the cloud requirements, Microsoft here suggests to use platform services such as App Services. This is the last point. Can we make the app cloud ready? And the next slide here, I put here the image from the Microsoft documentation. This is the step-by-step, how to say, way to select your services to deploy your application. Microsoft says that App Service is the best choice for most cases. But if you have microservices, it's maybe will be better to use other types of the hosts like Spring Apps or Service Fabric, or maybe containerization virtual machine, or maybe even Kubernetes in the cloud. But you need to understand that all these parts will be more, these services will be how to say, more complex to manage. You need to understand a little bit more about the containerization, about the, I don't know, the microservices architecture, etc., etc. So in most cases, App Service will be the best choice. Why? Because App Service can support different types of applications. So if you have a monolith application, if you have maybe several big applications that can communicate to each other, App Service can be a good idea here, because it works like that. So App Service is split into two parts. First part has name App Service Plan or App Service Environments, and second part it's like the control plane, and second part is data plane. It is the services that represent your application in the cloud. I will explain more about these two types, and for now, just let's note that App Service allows to run. First of all, it's HTTPS-based web application. This means that all the communication between this application, in general, like, will be mostly using the HTTP endpoints, HTTPS endpoints. Also, you can execute in App Services web jobs. Web jobs, it's something like, analog of plain task in the Windows Server. In Windows Server, you can create the plain task. You can set up the bat file or maybe exe file and set up the time interval when this exe or bat file will be executed periodically. But also WebJobs support continuous execution. So if you have some background tasks that should be implemented for your application, for example, I don't know, data export or data import to the database, maybe some conversion, I don't know. This is one of the best solutions here, and WebJobs also support continuous execution. And what is the difference between the main application in App Service and WebJob? Main application has the endpoint, public endpoints that, the main application can communicate, receive the requests and respond to these requests. WebJobs just execution of some script, execution of some console line tool, something like that. Also, we can deploy here API backends. We can deploy here mobile backends. All three, of course, this is the HTTP-based applications here. And we can use App Services to deploy also serverless functions and logic apps. Serverless functions, of course, it's the serverless. In general, they don't need any servers, but if you want to execute your Azure function on your already, how to say, created infrastructure in App Services, you can also deploy Azure function there. And Logic App, it's the Azure service, no-code, low-code service that can help you to automate some processes. So you can receive the webhook using Logic App and to make some steps based on this event, like email sending, I don't know, calling with Azure function or something like that. And all this can be deployed on top of App Service plan or App Service environments. So this is more general description, and also App Services that, how to say, we described more hosting model, but App Services gives you also some interesting feature for your deployment, for your management, like scale management. So it can help you automatically, like I showed you on the previous slide, scale your applications. It has some additional deployment tool that can help you to deploy your applications more easily. The development tools that can help you to debug your application or to edit some files to understand what's going on your server with, how to say, faster and more easily. And network management, very important part that allow you to control inbound traffic, outbound traffic, inject the App Services into the virtual network, private network, and for example, organize the connection between the database and the App Services inside of the private network, not in the public network, and some additional logging tools that can help you to analyze how your application works inside of App Services and get some insights from, for example, how your users use your application, which page they view most of the time, how many time they spend on every page, etc. So next we will jump into details of these features, and we will start from the hosting control. As I told you, the App Service split it into two parts. So it's App Service plan and App Service environment. And this is the control plane that controls hosting. It's encapsulate in general, this part encapsulate the infrastructure or architecture that I showed you before. So it contains the load balancer, it contains the hosts, control the hosts, and it also allow you to organize the network connection and set up, and manage the traffic to your hosts. Why we have two different names here? So App Service plan, it's more cheap and more common way to create apps in Azure, web apps, to deploy web apps in Azure. So it's the shared infrastructure. This means that when you create the app service and create several hosts, this host can be physically deployed on the physical server together with the other clients. Of course, this means that there will be good isolation. Nobody will switch the data between them, so everything is fine here. But in this case, you share the CPU, you share the resources, hardware resources with you can share with someone else. If you want to have the separate compute infrastructure, you can create app service environments. And in this case, all the server, all the CPU, server CPU, and memory will be created for you. In this case, you will pay more because you will rent as minimum one server here. And if I remember, it's something like 10 virtual machines, 10 hosts or something like that. This is the minimum size of the cluster here. And also Azure App Services allow us or you to have up to 200 hosts in scale. So you can execute more, how to say, you can have more power, more CPU, more compute resources for your application. App Services can give you only up to 30 instances. What else? App Service environments directly will be deployed inside the virtual network in Azure, in the cloud. App Service plan will use some special additional resources and special setup to organize access from and to virtual networks, to the private networks. And based on that, so the scenario for the app service, it's the common scenario. For app service environments, it's better to use this service only if you have really huge application that requires a lot of resources. And one more thing, these app services in Azure also support the pre-reservation, so you can have up to 55% of the discount if you will pre-reserve the service for 3 years. Next part here is environments. Deploy which application, which type of the application we can deploy to app services. So first of all, of course, it's the .NET. And yes, app services supports 2 operation systems. It can be Linux and Windows operation system inside, but you will not have full access to this. It's not like a virtual machine. So you can't connect there by RDP. You can connect by maybe PowerShell, some FTP, some additional tools, but you will not have the direct access to the hosts that are created inside of app services. And on Windows and Linux, we can use .NET, new modern .NET, applications like 9, 8, or 6. It's long-term supported versions. We can use old versions like ASP.NET, 4.8, 3.5, a lot of different Java versions. And for example, Java SE and Apache Tomcat hosting we can use on Windows or Linux, but JBoss, I don't know what is JBoss, truly say, but it's also like some kind of the web hosting here. It can be installed only on Linux system, not JS, Windows and Linux, PHP only Linux, and Python also only Linux. I don't know why Microsoft decided to do that, but PHP and Python can be used only on Linux. Also about web jobs. So web jobs can be executed also on Linux, on Windows. On Windows, this is the main feature. On Linux, this is the previous feature here. And in Linux, you can execute just the shell scripts. On Windows, you can execute a lot of different types of the application. So it can be the classical exe file. It can be Java packages, Node.js packages, Bash scripts, PowerShell scripts, and just the command line, typical command line scripts. And moreover, in Azure, in Marketplace, you can find the predefined templates that can create you Azure App Services with the installed WordPress, Joomla, and Drupal. So it will be ready to use installation if you want to create something like that. And one more thing here about the scale. So on this slide, I put 2 parts of the scale management. So there are 2 terms. So scale up, scale out. Scale up, it's like the size of the host that will be used inside of app service. And scale out, it's the horizontal scaling, like how many hosts you will have to support your application. And on the left side of the slide, there is the list of the possible options, possible sizes of the servers, of the hosts. There are a lot of different sizes, very cheap and very expensive. And also there are a lot of different plans. So every size, some sizes can be the same in different plans, but different plan will support different features. Usually the difference here is, for example, how many hosts you can create, or how many application you can deploy, because in the same app service plan you can deploy several applications, how many network connections you can do, etc. Some feature differences. And next part that after we discuss the hardware part, no, not hardware, but hosting part, we need to discuss the next thing, how to deploy. So we created the Azure App Services and we want to deploy our application to Azure App Services. There are two typical ways how to do that. So first one is FTP and web deploy, and second one is Kudu. Other name is SCM, Kudu endpoints. Kudu is the special middleware software that will be deployed when app service will be created, and this software is responsible for a lot of features that we will discuss a bit later. For example, that's Kudu who execute web jobs. Kudu has, for example, some additional features like deployment automation. So one of the way, I will give you the description on the next slide. For example, continuous deployment. So you can, it supports GitHub, Bitbucket, and Azure repos. You can put the link and the credentials to the GitHub repo to the app service. App service will automatically receive, for example, you can set up a webhook when you make commit to one of the branches. Webhook will be cached by app service, and app service will download the code, get the code, then compile it, and then deploy it to itself, to its host. So in this case, you even don't need to have any CI/CD pipelines outside of app services. So it's only one of the possibility here. Other possibilities are just the FTP access, so you can access to the app services and its internal folders by FTPS protocol. You can upload some packages like zip or jar packages, and app service will automatically extract them and put in the right place. What else? Also, you can deploy locally from your own local laptop, for example, to the app service using Git repository. Of course, you can use Azure pipelines and you can use Azure Actions. And the idea here that all these possibilities are using the same 2 points. So most of them are using just FTP, and some of them are using Kudu endpoints. What else? And one more interesting thing here, and maybe even one of the most important features of app services, it supports the deployment slots. What is the deployment slot? It's the copy of your application on the same environment. So if you need to have, for example, the production environment, several staging environment, development environment, you can use several deployment slots. They will be deployed on the same hardware, same hosting, and you will be able to easily switch between these deployment slots. For example, the scenario when you have the production, you deploy your code to the pre-production, make the tests over the pre-production, and when you think that everything is fine and the pre-production can be deployed on production, you just switch the traffic between the old production environment and new pre-production, and old pre-production environment became now production environment. Sounds a bit complex, but it's very simple, it's very fast, and moreover, you can control your traffic and you can set up the percentage of the traffic that will come to different deployment slots, and this allows us to support different deployment strategy like A/B testing or canary testing, canary deployment, etc. So this is very cool, and I love this feature, and I think it's very useful here. Next thing is about the development. So we understand how to deploy our application to app services, but now let's check which tools we can use to support to debug it, and to understand what's going on there, to make some configuration. And App Services has here several tools. First of all, you will be able to have access to the console, Windows console, CMD console, and SSH connection to the Linux. Only one thing here is that it's not full-featured console, so some services and some commands can be deprecated here. Why? Because it's the managed service, and the managed means that some features, like I told you before, some features will be implemented and will be controlled automatically by the cloud provider, and this means that the access to some parts of the host will be deprecated for you. But just to check the files, just to upload something, just to view the state of the operation system, and for example, to make the network connection test, or to ping something to check if the resources are accessible, you can use these tools. The next one is I already explained you that this is the special middleware that will be installed on top of your hosts in App Services. Moreover, it's open source software. They have the GitHub page with all the detailed description of Kudu for Windows and for Linux, and you can install this Kudu to your own virtual machines, or even to your own host, your own laptop, and it contains, Kudu has several different interesting features. So first of all, in Windows, of course, we can get the full description and the list of the environment variables. We can get the list of the services. We can have access to PowerShell console and CMD console, I mean in Windows. And we have some site extensions. So on Windows side, this is the next slide. Kudu supports a lot of different extensions that can give you more features, more possibilities. I don't know, like additional logging, like more interesting or more features for the remote debugging of your application. So it's like gallery of the extensions that you can install, and this gallery also can be accessible not only from Kudu. To access Kudu, you need to enter, so it will be done by the special link, so you will connect directly to your application. But also you can install the extensions from the user interface, from the portal of Azure itself. And if you will talk about Linux, so for Linux we have also Kudu. It has less interesting things, but still. So you can connect by SSH and Bash. Also you can check the log streams, and you can have the list of the environments. But we don't have here any extensions. So this is the really good instrument. I'm using that very often, especially if I need to work with the folders, if I need to, like I told you, organize and check some network connection. And one more thing, interesting thing here, it's only for Windows, it's in the preview state, but it is the editor. So you can open, it's the Visual Studio Online, Visual Studio Code Online, that can be used to view and modify your files directly on the App Service for Windows. You can open anything, you can read anything, and you can edit files you want. Moreover, if I remember, you can even maybe download, but not, you can create files, not upload, but create files here. So it's also a cool thing to do something with your application. And for example, to check logs without any additional steps here. About logging, we'll talk a bit later, and now we need to describe one more feature here. App Services contains the built-in authentication. So this feature can help you to organize connection and work with the authorization and authentication of your application. So it's like middleware that will catch all the responses. You can use all the modern identity providers. And later, after when this part will work with your users, authenticate user, you will receive the GVT token that will have all the requirement claims. Based on that, you can organize access users to your application. So you will not be needed to implement any additional steps to organize the authentication and authorization here. So it can be also very cool. It has the name Easy Auth. The next part, so we made the review of the main development parts. The next thing is the networking. So networking is very interesting part here because it's very flexible. It can help you to control the inbound connections, outbound connections. So first of all, your app service will be exposed to the internet. And here, if you want to control the traffic, so you can expose for everyone. You can use the firewall to select the IP addresses or the range of the IP addresses, some subnets from where users can come to your app services. And moreover, you can organize access separately to your application and also to Kudu, because Kudu has also the public access, public endpoint that can be connected by default from everywhere. And Kudu also uses the Microsoft Identity Authentication. So FTP use the basic authentication, authorization and authentication. Kudu requires the Microsoft account. So if you just come to Kudu, you will be needed to enter your Microsoft account to be able to have access to its interface. So here you can control the public traffic and you can disable public traffic. For example, most of the applications that we are working in our company, they are internal, so they have no public access. And for that, we integrated app services inside of virtual networks. And here we have two interesting things. So inside of app services, because it is it has the scaling feature, they splitted the traffic. So for the inbound traffic, all inbound traffic will come to the load balancer, and it's simple. You just can create the private endpoint and connect this private endpoint to the virtual network, and it will have the private IP address. So you will disable the public IP address and we will use just the private IP address. If we want to control the outbound traffic and allow access from the app service hosts to the local resources, we need to organize virtual network integration. And here you need to understand that since we can have a lot of different hosts. For app service plan, it's up to 30. For the app service environment, it's up to 200. We will have in the UI, in the portal, in Azure portal, we will have the list of the public IP addresses that will be used to connect throughout the public network, throughout the internet. For example, if you want to organize the connection between the database and your application throughout internet, and you want to restrict access for the database by the list of IP addresses, you need to put here some long list from this UI, and the same for the internal network. But for the internal network, when you organize the network integration here, you need to create before the subnet. This subnet should contain, if I remember, is minimum 32 IP addresses, and it should be delegated to the app services. So when you connect your app service for outbound traffic to some virtual network, this subnet that will be used in this connection will be delegated to app service, and nobody will be able to use, no other services will be able to use this subnet. And you will receive the list, you will have the list of the IP addresses that can be used to send traffic to somewhere, to connect to the database and to some other resources. You will have this range of IP addresses inside of your subnet. And here, since we are talking about the network connection, you can also set up some additional things, control the traffic, should be outbound traffic organized throughout the local network, or you will have the local connection, but public traffic that goes to the internet will go directly to the internet. So there are a lot of different options here. But I want to mention here one important thing that I've got in my experience. It's about the timeouts. So when the request comes to App Service, and if you will have the long-term operation, there is a timeout for 230 seconds. Why? Because we are using the load balancer. Load balancer use this timeout to measure to make the health check of the hosts. So if host will not respond during, it's something like 4 minutes, during 4 minutes, the load balancer will think that host is down, and the balancer will return timeout to the client. So if you will have some long-term operations, it's to use them inside of App Services, you need to move them to the asynchronous pattern, so you need to respond as quickly as possible here. And on the next slide, we have some kind of example of the architecture here. So we can use network integration to connect to different resources in the cloud. K-vaults, it can be some, I don't know, cognitive services, file shares, databases, so something that you are using, or if you want to organize some network integration between different services, it can be also implemented here. And here we have one more important thing. So since for example, the database that will be created and connected to the virtual network, to the VNet, we need to redefine the DNS, because the database has its own certificate. And if you want to have secure connection, even throughout the local network, we need to redefine the DNS server. For that, we can use the private DNS in Azure. And this can help. This will define your old URL to the new local IP address only inside of the virtual network. For the public connection, for the public internet, the IP address of the same URL will be exposed to the public IP address. And some services you can control. So for example, to the database, you can connect using just IP address and put their trust server certificate through. So this will skip the errors of the server certificate. But for example, to make the connection to the shared folders, SMB folders, you must redefine and you must create the private link here, because it's the managed feature, and it's not possible to attach the SMB file share that is not part of Azure storage. So there is a Azure Files and Azure Blob storage that can be attached as file shares to the App Services, but it will use some additional protocols, not the standard protocols, and you can't use the standard SMB port, and it's not possible to attach or to get the files from the old file shares inside of the network. So this is one of the restrictions, and for that, since this is the managed feature, service, you will not be able to set the IP address. Service will take the URL of the file share automatically from your settings, and since it will be the public URL, you need to redefine this public URL using the private link. So this about the networks, and one more thing here about the networks, it is domain and certification and certificates. So of course, I think it's also always the good idea to attach the custom domain, because Microsoft uses its own domains, subdomains, etc. And here you can attach to the service or your custom domains. So for that, you need to write some TXT values and CNAME values in your domain, or you can buy directly the new custom domain from Microsoft. It's also possible not to use some external services to manage the domains. And at the same time, when you attach the domain, you need to create the certificate. Why? Because it's not possible from the app services to work without certificates. And even if you want to open the application using the IP address, the connection will be failed. And for these cases, if you use the custom domain, you need to upload your certificate, for example, that you can create in Let's Encrypt, or to create the managed certificate inside of Azure. It's free. Managed certificates in Azure in App Service. The certificate will be created for 1 year and automatically will be recreated every expiration time. And also I mentioned here about files. So you can connect Azure files and blob storage. You need to redefine DNS name here, and only Azure service. No SMB, existed SMB file shares. The next thing is the web jobs. Web jobs, I already told you that this is the periodical tasks that you can execute. They can be, yes, periodical. They can be long term, and periodical tasks can be executed by the timer, by the cron, or it can be executed by the manual call from the UI of Azure portal. And what is the job itself? So job is the special folder inside of the file system of App Service. Inside of this folder will be created the folder with the name of the job. Inside of this job folder, you can put your script or your execution file or your, I don't know, your bash or, I don't know, some package together with some parameters. And the second file there will be the configuration of this job with the cron timer or other settings that you can set up here. And once again, on Linux, you can use, it's the private mode, not private mode, it's the preview mode. In Windows is the production mode. And one more important thing here. So since the web jobs are executed using the kudu, you need to manage them, you need to have access to the kudu. If you will restrict and close the access to kudu, you will not be able to connect to and manage your web jobs from Azure Portal, because Azure Portal uses the same kudu, the same things to connect to your app services and manage the web jobs. And last part that I want to mention here is about the logging. So App Service supports the standard Azure monitors, where you can create your dashboards, your charts, when you can create your alerts based on some metrics. Alert can send you some events. It can be the SMS, it can be the email, and in the United States it can be also the voice call with the explanation of the problem. So this is the typical things for all Azure services, but App Service also supports the advanced logs of your application. So there are two types of logs: logs from your web server and logs from your application. So you can select the storage for these logs. You can deploy and put your logs inside of the local storage of the hosts, or you can attach external logs there and use the external storage to collect your logs. And if you deploy your logs inside of the hosts, inside of the app service, you can connect there using the FTP protocol. And this one is very fast and easy way to get your logs from your application without just come to portal and open the page, and you will see the last logs that your application created during its execution. And next thing is application insights. This is the powerful tool from Microsoft, from Azure, that allow you to get a lot of different insights from your application. You can build the reference maps of your application. You can receive the advanced monitoring, a lot of information and logs of using your application by the users. As I told you, it can be usage details like how many users right now in your application, which page they are visiting, how long they spend on every page, which buttons, for example, they are clicking most of the time. So it can be very useful for the product owners and for the UX analytics of your application. And application insights also support code analysis, and it can give you some advices about the security, for example, of your code. So very powerful and very interesting instrument, and you can use standard way. Log Analytics tools from Azure. Log Analytics, it's the special workspace that allow you, it's like Elasticsearch, so it allows you to make some requests on the special language with the name Cousteau. Cousteau, it's like the SQL. It's very, it looks like the SQL, but with some additional syntaxes that allow you to search the events, the things inside a big amount of logs from your service. So because you can receive logs from the host, from the load balancer, from the application, from the web host, so it can help you to analyze the logs part here. So that's the last slide that I have. It was quite fast and hope it was useful for you. So I would like to tell you thank you. And if you have any questions, please, you are welcome.
If there are any questions, please raise your hand. I will give you the mic. Or if not, in
Okay.
3:15 is the next session, and we can thank you.
Yes, so we are in time. Thank you very much for coming, and
Yeah, we are in time.
enjoy the conference.